you ever wondered how exactly gravity, freefall, and forces work? I know it might seem complicated, but I'd like to help you figure it out.
Let me introduce you to one of the most influential minds in all of physics, math, and science, Sir Isaac Newton. Newton first became curious as to how gravity worked throughout space when he saw an apple fall in his orchard. This well-known story is believed to be what sparked his idea that the same force governed the motion of the moon as well as the apple. He wrote in his books his calculations as to what held the moon in its orbit and compared it to the force pulling the apple to the ground. Let's move on to forces. There are different forces that act on objects constantly, but all of these can be divided into two main groups: contact forces and long-range forces. Contact forces are forces that act on objects through contact points, such as a normal force. A normal force is the force exerted by a surface against an object that is pressing on the surface. In contradiction, long-range forces are forces that act on objects without physical contact. One type of long-range force is drag, or air resistance. This is the force that holds back objects from smoothly traveling through the atmosphere. However, the most well-known long-range force is gravity. The force of acceleration due to gravity is equal to 9.81 meters per second squared multiplied by the mass of whatever the force is acting upon. The force of gravity, or Fg, is equal to mass in kilograms multiplied by acceleration measured in meters per second squared. Now that whole measurement is complicated and long, so we just call them newtons, or N for short. We measure weight in newtons and mass is measured in kilograms. A brick on the surface of the Earth has a mass of 1.5 kilograms and a weight of 3.31 pounds. These can be used interchangeably here on Earth due to the constant of Earth's gravity 9.81 meters per second squared. However, in order to have a weight, a mass needs a force of gravity. If you took the Earth away, the mass would still be 1.5 kilograms, but the weight becomes 0 because there is no acceleration due to gravity. If you took the same brick and put it on the moon, its mass would still be 1.5 kilograms, and it would have weight again, but because the moon has a different acceleration due to gravity, the brick would weigh 0.53 pounds. Weight is relative because it depends on acceleration due to gravity, but mass is always constant. An important concept involved with gravity is free fall. The laws of free fall describe that any object, regardless of its mass, will fall at the same acceleration as another object if they are dropped at the same time from the same height. Imagine you're on top of the Eiffel Tower and you drop a bowling ball and a tennis ball at the exact same time. Disregarding air resistance, which would hit the ground first? Most would say the bowling ball because it weighs more. Actually, they would hit the ground at the exact same time. This is because both objects have an acceleration of 9.81 meters per second squared. Now you still might not believe me, so let's try it.
Alright, right now I'm holding a wiffle ball in one hand and a brick in the other, and I'm going to drop them at the same exact time to see which will hit the ground first. Ready? 3, 2, 1, go. As you can see, they hit the ground at the same exact time. This is because they both have an acceleration of 9.81 meters per second squared. Now what would have happened if I had thrown one and dropped the other? It would have had the same exact result.
You see, in order to calculate how fast an object will fall to the ground, you need a few things: velocity and acceleration. Velocity is the change in position over time, and acceleration is change in velocity over time. So even if one object is moving faster, neither change velocity, so acceleration stays the same at 9.81 meters per second squared. Overall, it's very important to understand gravity because without understanding the force of acceleration due to gravity, it would be impossible to do the things we can today, such as sending a rocket into outer space. Even today, there are many significant discoveries being made pertaining to gravity and its effects, and it's all thanks to Newton and his apple tree.